Okay, so what we're going to be working on today is a new feature for the Ohm Editor. So in the Ohm Editor, if you haven't seen it before, you can edit your grammars here on the left. And on the right, you can have examples. So these are strings that should be matched by the grammar, by either the start rule of the grammar or by a particular rule in the grammar. And one of the problems we have is that, if you're working in the editor here, you might add a bunch of examples. We have no good way of exporting these examples, so that you can insert them into your source code to use them as tests or something. They're basically kind of stuck in the editor, and you have to manually move them into your tests if you want to do that. And so I had an idea to do something similar to Python doctests. So in Python, you can have these comments at the top of a function, and inside those comments, you can include examples. So basically little snippets from a REPL session that demonstrate how the function should work. And those are intended to help people understand how the function works, right? Or how the function behaves. But the cool thing is the doctest module can actually extract, can read the comments, can run tests to make sure that your function behaves the way that the comments say that it does. And we want to do something similar for the Ohm Editor. So we want to add to the Ohm grammar format, or actually I think what we're going to do is create a subgrammar. So extend the main Ohm, the grammar to the grammar of Ohm grammars. We're going to extend this and add support for comments, which can have examples embedded in them. All right, so let's get started. We'll jump over to VS Code. So I'm just in the Ohm mono repo here. I'm going to create a new package for this. Let's see, I will call it grammar Ohm with examples. Very nice and long and descriptive. And let's just initialize a new package here. We have some dependencies. Let's see, we need to depend on Ohm. And we also, want uvu and watch list. We've added all of these to our dev dependencies for now. Uvu is a testing library that we're going to use. So let's see. We also, I think, should add this to our top level workspace, pnpm workspace file. Actually, I don't need to add it because we have this packages/star here. So everything in the packages directory is automatically a pnpm workspace, which is nice. Okay, let's see, grammar with examples. We have our package.json, pin it here. So let's create two source files, index.js and index.test.js. We also need to put type module in the package.json so that we can make these ES modules and use import rather than require. All right, let's, whoops. What just happened? Grammar with examples. Okay, let's open up our index and the tests. I'll pin both of these in the editor. All right, so the idea I had is something like this. So we're in index.js here. We'll write a function like extract example. It will take some input this is actually like a grammar definition, so let's call it grammar def. And the idea I had is that it returns something like this, so that we return an object where the keys are rule names and the values are, each value is an array containing examples for that rule name. We may need to make this a little bit more sophisticated, because this doesn't say whether the examples should be matched by the rule, or like basically it doesn't say whether they're positive examples or negative examples. I think we're going to want to have negative examples too, so things that shouldn't be matched by the rule. You know, so we could, yeah, if we want to make this a very explicit format, we could do something like this. Yeah, example, or maybe we say call that input. We could also take a look just at what we should match. That's the same terminology we use in the editor. Yeah, why don't we do this? Why don't we say the example is a string and we have a should match true or false. That seems reasonable to me. All right, I'm just going to return an empty object here, and let's go over to our tests. I have a snippet that I like to use for this because I always forget exactly how to import everything from Uvu. You know, we can write the basic empty test. My escape key is broken on my keyboard, which is very annoying. Let's see. We need to import extract examples. It's not right, but there we go. Okay, so extract examples of an empty input should obviously return an empty object. We can make an assertion here. Let's actually run our tests, why don't we? Let's write a test script. So I think we can just use Uvu. Extract examples. What did I do wrong? Extract examples. Did I spell this wrong? What am I doing wrong? This is obviously something dumb. What am I doing? I have an exported function here. And I'm importing what the heck is going on? Okay, there was something. I have no idea what I just did. Okay, anyways, I'm happy it works. Our test is actually not running though, because with Uvu we have to add test.run. And it's not happy because extract examples, I'm doing the wrong thing here. Whoops. There we go. Good. Let's add a little test watch script, which uses watch list. It will watch the current directory. We make it eager so that it will run the test command before any of the files change. And the test command is npm test. So okay, now we can start developing. Okay, the empty one is pretty boring. Let's just do another boring test, a grammar with no examples. Grammar with no rules and no examples. This is going to pass. Of course, our function is just returning an empty object always, so this is not a super useful test right now. Let's try real tests now. So let's test some simple examples. All right, let's make our grammar a little bit more interesting. Okay, so we've got a language here. The only valid input in this language is the character X. Very awesome language. Here's the format I want to have. There's, of course, only one example. I need to escape the backticks here. Yeah, this looks good as a first example. And what do we want the argstruct examples to return? The rule is start. We return an array. Example is X. And we want should match, I think is what we said it should be. Should match, should be true. All right, not surprising. Our test is failing. Cool. Well, let's make it pass. All right, over here, we need to import Ohm. Now, how do I want to do this? So I think the way I want to do this is actually, I think I'm going to create a subgrammar of the main Ohm grammar. So, you know, for those that aren't that familiar with Ohm, Ohm has the ability to, you have this kind of object-oriented like grammar extension. So you can have one language which extends another language. And we have a grammar for the Ohm language itself. So when you write grammars in Ohm, you know, the syntax is defined by another grammar. So we have the Ohm grammar, which defines the language of Ohm grammars, which is wonderfully meta. So rather than modify the kind of core syntax for Ohm's grammars, I think what I want to do is to create an extension language. So this way, so Ohm itself will just treat these. I mean, Ohm already has support for comments. It will just treat the contents of the comments it did. It'll just throw them away. It doesn't care about them. And then any code that actually cares about the examples and wants to parse them out will use this subgrammar to match rather than the main Ohm grammar. So what we need to do then is we're going to create this new Ohm with examples, grammar, now there's different ways of writing Ohm grammars. You can just do it inline here in a string literal in the JS if you want. Typically I would probably stick this in a separate file, a .ohm source file. I find it kind of nice to have the grammar in a separate file, but it doesn't really matter. And for convenience right now, I'm just going to define it in line. So we want this grammar to extend the built-in Ohm grammar. Here we need to pass as the second argument to ohm.grammar. We need to pass an object, which is where it looks up any external references. We need to tell it, we need to pass in the Ohm grammar instance, which is called Ohm grammar. So this should all right, it looks like this at least works. We get a grammar. Let's just steal some assertions here and stick them in right in line for now. What do I want to do? Assert.ok, Ohm with examples, matches. Yeah, just that I want to assert that we can, that, you know, we've properly inherited the grammar and a regular Ohm grammar will match. And it does, which is not surprising. Okay. Let's open up the Ohm, the grammar for the Ohm language, and look at how it defines comments. So I think we want to override this basically. So you can have single line or multi-line comments. Okay, this is going to be a little bit trickier than I would have liked. But that's okay. Okay, so I think we need to override the comment rule. Can write it like this. For overriding, we need to use the colon equals. And let's see. One of the problems we're going to have is that Ohm has this, so Ohm does implicit space skipping, and that's where these comments get consumed. So it's a little bit tricky to get access to. So we can make a grammar that properly parses these examples, but it's a little bit trickier than I'd like to get access to them. Let's see. Yeah, so basically what happens is we will parse rules. And so rule star here means we parse, we try to match 0 or more rules. And the comments are basically implicitly discarded as by this. Yeah, so we can do something kind of funny. Okay, let's see if we can, this won't be as clean as I would have liked, but it's okay. So I think we can override this rule too. It's a bit unfortunate that we then need to kind of duplicate some of the logic that's inside of the main Ohm grammar. But I think if we don't do this, we won't be able to easily get access to the parse nodes associated with the comments. Okay. So before I parse a rule, so we need to make this colon equal. Basically, before we parse a rule, we want to try to parse a comment explicitly. So normally, if we go back to the main Ohm grammar, with Ohm's implicit space skipping, this space rule will get called implicitly before we try to match rules. And, you know, in this grammar, we've said a comment counts as a space. So what we've done here is that we want to first try to explicitly match a comment before the rule. We need to use this what's called the lexification operator in Ohm, to prevent Ohm from implicitly skipping white space before this rule. I hope this is going to work. In the end, this may actually not work the way I'd hoped, and we may need to actually make a few changes to the main Ohm grammar to make this possible. But let's see if this works. So, all right, so now we don't even have a valid Ohm grammar here. There is an error in the comment. Why? We got to escape our new lines as well. Or I could make this string.raw. Then we don't need to escape the new lines. Okay, so now we're back to our test failing, which is what we want. Okay, so let's modify this and let's see what happens if we insert a comment before this rule, and if we can get access. Let's see if we can get access to the comment. Okay, so this succeeds. You know what, I'm just going to move this actually. Never mind. I'll leave this here. Okay. So this is a match result. We're going to create some semantics and add an operation called get comment. This is basically just, I want to just a little scratch operation here to see if the space skipping is going to burn me or not. Okay. Then we want to assert I am a comment. Okay, so we want to try to extract this comment. Okay, so we only have, it's kind of confusing. I have to remember to think in terms of the Ohm grammar and not the grammar that I just wrote. Unfortunately, it's something is reformatting things on me here, which I don't like inside of my string. Or did I do that? Maybe I did that. Okay, so we need to, okay, we don't need to go very deep. It's inside this grammar rule where we match the comment. So we need to just define grammars, and grammars and grammar are the only two actions we need here inside of this operation. Let's just get the first child and call get comment on that. So we assume that there's only one grammar. And let's see, what is the arity of this? We have ident, or let's call this name. Super grammar we don't care about. The open brace. Then we have comments, rules, or comment iter. I like to write rule iter, and then close, the close brace. Right? Yeah, okay. Should we do the same for the comment iter here? Yeah, let's just do the same for the comment iter. That we just want the source string of the first child there. Oops, and okay, cannot, interesting. So this grammar is actually failing to match. Why is it failing to match? Okay, well. Let's print out the error message. It's expecting a close brace. Okay, I think the space skipping is burning us here. I think the lexification is not doing what I wanted, and it's not preventing it from skipping comments. So how should it, I mean, let's see. I can verify this by going over to the Ohm Editor. I'll cut and paste in also the Ohm grammar. I think this should work. Let's kill our examples here. And what's the example that's failing? Something like this is what we had. And yeah, it's failing to match. Oh, we have the wrong. I want it to match Ohm with examples. There we go. Yeah, so this is the same error that we had before, expected a closed brace on the S. Okay, so we're going to explain parse mode. This is kind of an advanced feature of the Ohm editor. It's a little bit tricky sometimes to follow how this works. And I can see here that it did, so the pink background here tells me that it did successfully parse this. I'll blow it up. It's kind of maybe hard to see on the stream. So it's telling me that this was successfully parsed. But then, wait, I'm confused. Of course, yeah, because it's a 0 or more, it will always be successful, even if it consumes nothing. So, yeah, it failed to parse the comment. Let's put in show spaces here. I think that will give us our answer about whether, okay, interesting. So what I wanted to happen happened. So this actually already shows me that the lex operator here, the little hash, did indeed prevent the implicit space skipping. Right, so you see, so in the editor, if you want to understand kind of where the implicit space skipping is happening, you can always click show spaces, and then you will see it explicitly. You'll see these spaces rules. I think that I see the problem here. So, this is tricky. Yeah, okay. So the problem is we have, you know, we actually have some white space before the comment occurs. We need to skip over that. We need to skip over this white space here, but we don't want to consider comments as a regular part of white space. So yeah, the lex operator is doing what I wanted. But we need to do something else. I need to look at the Ohm grammar again and think about this a bit more, about how we're going to do this. So I guess I may want to redefine. Ooh, okay. This is a bit tricky. So what we can do here is before we try to match the comment, we want to match spaces without consuming a comment. So let's add in a call here to spaces no comment. We again need to use the lex operator here to prevent the explicit space skipping, which would just match spaces and is going to end up consuming the regular comment. So let's define this new rule, spaces no comment. And it's, I think, pretty simple. As long as we can't consume a comment, consume a space, and we repeat that. You know, the regular spaces rule is just something like this. It's not defined in here. It's basically a native built-in. That's why you can't see the definition there. But we just want to do basically essentially the same thing, except we, in this specific instance, don't want to treat comments as space. And that will give us access to, that will let us then parse comment here, I believe. Okay, and we've changed the arity of the grammar rule because we added another rule application that we don't care about. Okay. And Uvu is saying they're not equal here. Let's just see what this prints, shall we? Good old console.log printing. I don't know if it's the I am not a comment or undefined. I am a comment. Okay, that's good. Where's the undefined coming from? Oh, this thing. Okay, that's good news then. Okay. So this kind of works. Cool. So I don't know if we should be using assert.equal or I thought we should be using assert.is here. Ah, of course. Oops. Okay. That's cool. All right. So now we're back to the failure in here. But that's good. So let's see, what do I want to do now? So I think I'm going to add like, I think I'm going to add a new function. Let's just call it temp, and or you know what? Yeah. And then I'll return the result of calling getComment right now from temp, and then I'm just going to keep iterating on this as my test function. And skip this one and add a test for temp. And then let's work. Okay, nice. All right. Well, we're actually not that far now from defining a real operation. Okay, how about this? Let's call this for now get rules with comments. And let's actually write this to, okay, I want to say get rules with comments. And we have start. So here's what we have. Start says I am a comment, and other, let's define a rule called other, which says me too. Okay. And let's add this me too. Okay. All right, so let's look at how we need to change our actions here. So the grammar, right now, let's just stick with the assumption that we have a single grammar. That's actually something that we'll need to think about in the end. We don't want this example format to return just an anonymous object. We actually want an object where at the top level, I think we have the grammar names. And then within that, you have an object which has rule names pointing to the examples. But that's very easy to add once we get to the end. So for now, we'll assume we have a single grammar. We want to iterate through the rules and the comments together, kind of zipped up. Can use object.entries. So yeah, the way Ohm flattens, so in this action, we have these three. Yeah, so this is actually spaces iter. So we have these three nodes, which are iteration nodes in Ohm, right? Because we have this expression here with an arity of 3, and we have the star. And the way that Ohm flattens these into 3 different iterators is sometimes really convenient and sometimes it's not. In this case, it's not, but it's no big deal. We're just going to use, we can just use a regular for loop. Just want to make sure that I remember how object.entries works. On an array, that I'm getting these arguments in the right order. Yeah, okay. So the first one's the index, the second is the value. Good, good. Okay. And then, right, so our comment will be the ith child of the comment iter, because basically iteration nodes have children representing each each step of the iteration. So if this expression was matched 5 times, right, each of these iter nodes in here will have 5 children. Okay, so we got the comment. Rules with comments. I'm just trying to think, what do we want to return at the top level? So it's generally a good idea in Ohm if your operations have consistent return values from every action. It can get a bit messy if they don't. Here we want to return, probably just, let's see, like I think we want to return an object from here, right, which is, then in here we'll do something like result at rule.sourceString. it'll give us the rule name. We could do it this way too if we want. Should we trim? Don't think we need to trim it. No, we shouldn't need to trim it. So result at rule name. Let's just make this nice and make this a one-liner. Result at rule name equals commentator.child .i. That's our string, right? This is pretty simple. I'm going to return results, and then why don't we actually make this return an object to this and then, or whatever, it's called child, and result at child dot that's kind of annoying. We'll have to return a new, or we'll have to write another little operation here to get the grammar name. Whatever, that's not a big problem. S.add operation grammar name. Grab the same pattern. It only handles grammar nodes. We don't need to define any other actions. We can just return name.sourceString. So this is just a little helper operation. Doing stuff like this comes in quite handy in Ohm. All right, so then now inside of here, I can call child.grammarName. We can make this an attribute. If we wanted, I don't know. It's kind of nice to, I mean, I won't make it an attribute. So if it's an attribute, it's just like a cached operation, and I don't see any reason that we need to cache this. So, right, okay. So the result at grammar name is child.getRules with comments. Okay, so now we're actually, even though I said we weren't going to worry about it for now, I think it's simpler to just already handle the case of multiple grammars. Okay, and what does this look like now? Temp is failing. Something is undefined. Which line? Comment iter. That shouldn't be possible. Oh. I just realized we have a problem here. This is not quite correct because this would enforce that every rule needs to have a comment. This is going to make it a little bit messier to parse because that gives us an iter within an iter, right? So we have an optional inside of a star. But that's okay because our test actually does have a comment before every rule. So why do we have an undefined? Okay. Why do I not see? Why do I not see an integer here? I'm expecting to see a node, underscore node. Ooh. Oh, shoot. Yeah, rule iter, I can't do this at all. Num children. I have to write this as a normal for loop. And then here we have rule iter child I, and then comment iter.child I. Okay, this should work. Of course, it does not. Num children is not iterable, right? Right. For let I equal 0, I less than old school for loop here. Okay. It actually almost did the right thing here. So we need to change our expectation to actually include the grammar name. What? Oh. And yeah, and basically it looks like the comments are correct. It's just that we need to be a bit smarter about how we're handling the rule name there. We're doing something wrong in how we're handling the rule name. So let's look at the right. So we didn't look at, we just called rule source string, and whoops, if we go over to the Ohm grammar, we actually need to handle all three of these cases. We don't want the full source string that includes like the rule name and the formals and the equals or colon equals or plus equals or whatever. So I lied before when I said that oh wait, no, this is grammar name. Should we define a rule name operation too? Probably. And the same thing, let's see, the rule is a pass-through, so we just need to define three versions of this. So rule body underscore define has ident, formals, desc. Let's do it this way, formals, desc. And the thing that we don't care about, the equals sign. we have the override rule body. Which is just ident formals op. And we have this version. Okay. And then in all of these, we just want to say return ident. That's our string. And then we want to call this operation. Does it work? Not quite. It's not a valid semantic action. Interesting. Rule body define. Oh. Rule underscore define, rule underscore override. Wow, that was dumb. That was dumb. Where are we? Rule underscore define. Rule underscore override. Rule underscore extend. Wrong arity. Wasn't really paying attention, was I? Yep. They all need the body on there too. The reason I use the underscore here is just as a convention to indicate unused variables. Don't need to do that. Oh, and now I'm using assert.is, which I shouldn't. I should be using assert.equal, which will do a deep equal. And this is now working. Cool. All right. Okay, now we need to handle, yeah, let's add another test here. This is kind of annoying, the way I'm doing this. Whatever. Yeah. Let's factor this out, move this into the test. Oh, temp needs to call a match. Oops. Pass in the grammar definition. How do I want to format this? Yeah, usually like that. Okay, why is it unhappy now? Grammar.mat. Oh, I'm not passing that in. Okay, cool. It's happy. All right, now let's make it sad. Because we will define a grammar that doesn't have any comments. Oops. And now it's going to be sad. Actually is working-ish. I think it'll be tricky. I'm actually not sure why this is working. I already made that an optional. Am I just getting lucky here in some way? Let's see, so I call, oh, yeah, I am kind of just getting lucky because I'm calling source string on the optional. Actually, in this case, that's reasonable. Calling source string on an optional is fine. I think we might get an empty string if it's not matched. We can handle that case. Yeah, let's make a bit of a more challenging test here. Let's just get rid of the first comment and add the second. Then what do we want? This might actually just work. Yeah, it does. Okay. Is that actually what we want, or do we want to not include it at all? Probably we want to not include it at all. We want it to be like this, so that if there's no comment, because it doesn't matter whether, I'm not sure whether we should exclude it here or exclude it at another point. Probably doesn't matter too much. All right, but cool. This is progress. So, all right, we're able to extract the comments that appear before the rules. Let's try maybe a 2-line comment. Right, we want to make sure that you know, so we should have something like it's kind of annoying, but cool. I see. There we go. So the comment, so this is failing because I think because we only matched an optional comment, and because we're using single line comments here, that's not enough. Oh, this is tricky. This is kind of annoying. We're going to get into a nested. We're going to have to introduce a bit more complexity to this rule, I think, because we have it here. Hang on, where is our grammar? Actually, we don't need to, I don't know why I added this here. We don't actually need to well, yeah, actually, let's leave this for now. I think we may want to override the comment to recognize. That's where we're going to add our, that's where we're going to match the text that tells us that examples are there. So yes, never mind. We do need that there. The problem is every time we match a single line comment, we could have leading spaces. So we may want to extract this out into a separate rule. Not quite sure what we want to call it. I think I may need to get a coffee soon. Okay, let's see. Comment fragment, maybe. So how is this going to work? We have basically actually, you know what? We might want to do it inside of our overridden comment rule. And re-implement or like redefine the single line comments. What I'm thinking is if you have like, you know, if you do something like this, and then, you know, you have a multi-line comment and then a single line comment. Do we just want to ram all of that text together? Or like you could also have spaces here. I don't know. It might be simple, you know, maybe we should make these, maybe I should require it to be a multi-line comment where the examples are defined. Could do like JS doc style too. What does JS doc even look, or whatever, Java doc? I don't know. Don't think I want to do that necessarily. But maybe it's reasonable to say that it needs to be a multi-line comment. That makes things a little bit simpler for us. We don't have to worry about combining a bunch of single line comments or combining single line and multi-line comments or anything like this. I mean, this still doesn't, we still need to handle this in some way in this grammar, because I think this grammar as it stands right now, if I'm not mistaken, it won't actually work if we have two multi-line comments. Did this work? Maybe I'm wrong. It does work. Why does it work? Why does that work? We have, so before a rule, let's just jam this into the Ohm Editor and figure it out. Oops. Is this using the most recent version? No, it's not. Right, this was the one that we debugged already. Okay, it works. Why does it work? Let me just simplify the string here. Oh, okay. Right. So it will invoke the regular spaces rule. Yeah. So it invokes the regular spaces rule, not spaces no comment. Before it parses the rule, and so it will consume a regular comment. So basically what will happen here is when we're ready to parse a rule, so at the beginning of the grammar or after we finish parsing a rule, we'll skip any non-comment spaces. Then we'll try to parse a comment. Then after that, if there are more comments, so if we have like a multi-line comment and then if there are multiple comments, so multiple single line comments or multiple multi-line comments before a rule, then we will only match and keep the first one. The others will get discarded because they're matched as part of the spaces rule. Oh yeah. So do I want to do this? This is definitely one of these places where Ohm's implicit space skipping makes things a bit tricky. So I'd say for 90% of grammars that you write, Ohm's space skipping rules do exactly what you want. And when they don't, it can be a bit tricky. I think in this case, I think we can just do this. Like, we can make this whole thing a lexical context. Let's go back and see what happens then in the editor if we do that. If the whole thing is a lexical context, then let's see. This, oh, yeah. Okay, well, it's not actually legal. Okay. Yeah, really, I think this is somewhere where we should make it easier to get access to the comment. So when we skip spaces, we need to make it easier to get access to the stuff that was parsed by the spaces. It's something we used to have, but the API was a little bit funny, and I think it's in a very early version of Ohm that we had this, and we got rid of it. Okay, in principle, this I think works. This should. Oh, I thought this was going to fail. Why does it work? So we go spaces, no comment, then we parse the comment, then. Yeah, okay. Then at the beginning of the rule, we'll still consume spaces. I think I might do like leading or like a rule comment. To find a new rule here called rule comment or rule what's the word I'm looking for? Yeah, whatever. Rule comment, good enough. So a rule comments, yeah. And right, the 0 or more comments at the start of a rule. And then but it's the same here. We need to do we need to put the spaces, no comment. Right, and then I mean, we could add this, I guess, to the rule definition too. No, but we still need to avoid skipping leading spaces. We need to ensure that we don't implicitly skip leading spaces there. Okay, but this seems decent. So is it actually doing, yeah. Right, and we can add, is that gonna work? Okay. Now, comment needs to be optional, right? Because we want to make sure that this, oh, it worked. So why did that work? Rule comments parsed. Nothing? But why did kind of a bug here in the editor too, like it's not supposed to. Never mind. I don't think maybe that's not a bug. Okay, actually, yeah, maybe this. So if there's no rule comment, then our implicit space skipping does what we want. This may just do what we want then. Okay. Ah, now we got to rewrite some of our actions. Okay, so the grammar has the wrong arity. Grammar. Whoops, over here. What action get rules with comments? Rule comments iter, right? Oops, where did my we'll need the same thing down here. Now we're going to want to strip the comment. I mean, we needed to do this anyways. So we don't want to just call source string on it. How do we want to do this? So we didn't institute our rule of making it requiring a multi-line comment. But I think the examples format I had in mind is anyways multi-line, so maybe we don't actually need to require it to be a multi-line comment. But I mean, maybe effectively it will be required to be a multi-line comment anyways. So let's leave this as it is. Okay, let's see. So I think we want to take the last comment for the rule, right? Iterating over the rules. I forget whether we have a way of getting the last child, first child, last child. Yeah, bingo. Right, so I think we want to do something like this. Rule comments iter dot last child, and that's a method. Last child dot source string. What is our terminal? What is our test telling us now? Last child is not a function, isn't it? Why is last child not a function? I see. Yeah, I'm doing this wrong. Okay, this is not where I want to call last child. I want to go child I, which gets the all of the rule comments for the ith rule. Basically, we have a iteration over rules together with their comments. Then we don't just want to call source string on the complete. You know what? Let's just call source string on the complete rule comments here. That'll give us the full string. Yeah, including white space. Should we trim it? Should. Did I change one of my tests here? Yeah, I did. Okay. Right, and then so I think this will need a okay. All right, they're passing now. Okay. Maybe now would be a good time to commit some of this stuff, huh? Oops. Right. Let's just, I'm in the total wrong directory here. Wait. Oh, I see. Got some other stuff that I was working on here. Let's see. Grammar with examples. And let's save. Oops. Did I accidentally? Oh, right. Stash doesn't want to stash that. Git is fun. I think this will work. Yeah. So I stage it in order to get it to stash it. Thank you, Git. All right, this is a good start. I think the next thing I want to do is strip off the leading comments, or like the comment characters, and just get at the raw text of the comment. But I don't know where I should do that because, yeah, I'm not sure. But I think I'll call it pause for now, and yeah, maybe come back in this video or another video and continue on this. All right.